problem number 4. We have 9a squared plus 3ab squared minus 9ab minus 3b cubed. First thing we should look at is standard form. Standard form is a little tricky in ones like this, but remember the definition of standard form is the highest degree first, and then after that alphabetical order. So what's the degree of this first term? It's 2. The degree of this term is 3 because 2 plus 1. Degree here is 2. Degree here is 3. So we need to put the highest degree first. Between these, we then go in alphabetical order. This one has an A and this does not. So 3ab squared will go first, followed by 3b cubed because they have the highest degree, and then we did alphabetical. Now let's look at these. They both have the same degree, so now we need to go alphabetical. This has more A's than this one. So then we have 9a squared minus 9ab. Now that it's in standard form, I want you to go ahead and factor this one out and then check back and check your work with me. Okay, you did it on your own and now it's time to check it. First thing we ask ourselves is there a GCF? Is there something I can take out of every single term? Well, looking at those numbers, 3's and 9's, we can take out a 3. What about A's or B's? I see A, that does not have an A, so A can't come out of all of them. What about B's? I see B squared, B cubed, no B here, so we can't take out a B either. 3 is the only thing we can remove. When I take out that GCF of 3, we're left with AB squared minus B cubed plus 3A squared minus 3AB. So we took out the GCF. Now we have 4 terms, so it's time to group. So we group these together, and take out the GCF of each part. This 3, just leave it for now and we'll bring it down later. So AB squared minus B cubed. What can I take out of both of those? I can divide each of them by B squared. I see they both have B's, so I take the smallest exponent, which is B squared. Well, there's my GCF. Now what am I left with? Those B squareds cancel, I'm left with A. B cubed over B squared gives me B. Bring down our plus. Now looking at this second group, what can I take out of both sets of parentheses? Well, no, not parentheses. What can I take out of both of these terms? Well, 3a squared and negative 3ab, they both are divisible by 3. And then a squared and a, I can take out an a from both. Remember, we look at the variables. If they both have them, we take the smallest exponent, a. Can I take b's out of these? No, this term does not have a b. So 3a is our GCF of that part. Well, the 3's cancel. A squared over a gives me a, minus 3's cancel, a's cancel, left with b. Okay, what should we have in common here? We should have this common factor in our parentheses. So don't forget to bring down your GCF. Now we write our common factor of a minus b, and then we group together our leftovers, b squared plus 3a. Now we check for difference of squares. This one is a difference, but they're not perfect squares. This one is not a difference, so that's disqualified. Last thing, just a little note on how we like to write them. Is this one in standard form? Yes, it is b squared plus 3a. But it is okay if you also write it as 3a plus b squared. As long as you have all of the correct factors, it doesn't really matter which order you write them in. So this is our answer, and this is our answer because they mean the same thing. On a similar note, if you wrote the a minus b after this set of parentheses, also fine. Just make sure the GCF comes first. So now you'll need to do the back of those 11-8 Day 1 notes, and that will be checked in class tomorrow for homework.